Hey guys, today I'm going to show you how to make, well, I'm not really going to show you how to make, I'm going to show you my design for a brake light strobe kit for your car. If you don't know what that means, basically just when you press on the brake pedal in your car, the brake lights will strobe once. So it's like they teach you in driver's ed when you're supposed to flash your brakes before you turn them on. It does it automatically for you. This is my completed circuit, and then here is the schematic. I'll have the schematic uploaded to a link down in the description, so you can find it there and you can order your own parts and build it yourself. I'm going to explain kind of how the circuit works, and so let's jump right into it. Let's see, F3. Okay, so this is the actual circuit. So this is the actual circuit that I have in my car, or not in my car, but I'm going to put in my car. But first, this is a simplified circuit. It allows me to demonstrate how this kind of works. So let's kind of work backwards from this. What we have here is, here's your step up transistor. So this takes 12 volts. It takes a 5-volt signal and steps it up to 12 volts, which is in series with your brake lights. So when this is on, okay, so basically when this is at 5 volts, then the drop across this is 0, meaning your lights are on. When it's at 0 volts, then the drop across this is 12 volts and your lights are off. So you take a step back here, and then you have the inverted exclusive OR gate. What this does is basically when you have a 0 and a 0, or a 1 and a 1, then the output is 1. If you have a 0 1 or a 1 0, then the output is 0. You know, simple truth table stuff. Then you go back one more level and we see the Schmitt triggers. If you don't know what a Schmitt trigger is basically a device that takes in an analog signal and converts it into a digital signal. The way that these are set up is once the voltage goes above 2.5 volts on the capacitors, then the output of either of the Schmitt triggers goes high to 5 volts. Down at the bottom, this first capacitor, the Schmitt trigger also turns on a transistor for the second capacitor, which allows the second capacitor to charge. Because otherwise, this kind of represents an infinite resistance and doesn't allow this second capacitor to charge until this is turned on. Because once it's turned on, then it drops like some 0.5 volts or something and shorts the circuit across here, which then allows the second capacitor to charge, which then triggers the second Schmitt trigger, and so on. So let's kind of go through this here, and I'll show you step by step kind of how all this works. So initially, your lights are on because this is a 1 and these are zeros. And the voltages at this are 0 and 0. You step on the brake and 5 volts starts to go into here, and it charges this capacitor up to 5 volts, which then turns this on, which changes this to a 1, this to a 0, and turns your lights off. At the same time, it allows this transistor to start charging. So you have the voltage going in here now. So then this gets to 5 volts. And once that goes to 5 volts, then this Schmitt trigger triggers, and the voltage goes out of here to this, which becomes a logical 1, which turns this back to a 1, which turns your lights back on again. And that's pretty much it. If we go up one more level, then we have the actual circuit that I was working with. So here's the actual thing that I built. And so it operates on basically the same principle. Here are your capacitors. You have your 5-volt regulator. This right here is the first Schmidt trigger. And this right here is your second Schmidt trigger. Then this right here is your exclusive OR gate, which is a NX OR. And we'll just draw the things here. So this is the Schmidt trigger, and then those are your capacitors. One other thing I was going to try but didn't end up actually putting in is I wanted to make a way to be able to discharge these when you take your foot off the brake pedal. And basically that just operates by using a PNP transistor, which then basically, let me get it drawn here. So when the 5 volts is on, then this is open, because PNP basically is the opposite of an NPN. When the voltage is high, it's off, and when it's low, it's on. So when the voltage shuts off, when you take your foot off the brake pedal, then the voltage here will become 0 volts, which shorts the capacitors to a resistor, which then goes to ground and allows them to discharge really fast. That way, basically, if you have to pump your brakes, like if you start slipping on ice or something, then it allows your capacitors to discharge between every single brake pump and flashes them every single time. Otherwise, if you pump your brakes too quickly, then the capacitors won't have a time to discharge, and you basically, when you put your brake back on again, then your light will just stay steady. But I actually found that this had a negative effect. It was allow the 5 volts to basically bypass this and just go through here and instantaneously charge the capacitor. So I just took this part out, and it actually worked perfectly fine without it. So I'm just going to leave it out. But if any of you guys have problems with it, here is the solution. One other thing that I ran into is because I don't really know how to build a Schmidt trigger from scratch, I had to look up kind of how other people do it, and I found a template circuit, but this template circuit has a low voltage of 1.4 volts, which is too high. So if I didn't have these diodes in here, then both of these would be high all the time. It doesn't drop enough voltage. 1.4 volts is enough to trigger a transistor. So I put in these diodes. Theoretically, you should only need 2, but when I was trying it, I ended up needing 4, because these they only drop like 0.2 volts instead of the 0.7 that you would expect. So I don't really know what's going on there, but you need 4. And just by trial and error, I know that. One way you could do this without having diodes is if you used a comparator, something like that. I'm not sure if that's right or not. Don't at me. But basically, a comparator goes high when the input goes across a certain threshold, and then goes low when the output goes below a certain threshold. And in this case, it would allow you to take the 1.4 volts and convert it into ground. Basically, it changes the reference point from the 1.4 volt reference to ground. Or you could just use 8 resistors and not put any ICs in your circuit because you're a badass. So that's basically it. If you have any questions, just drop me a line in the comments and I will help you out. Next, I have a demo. Here's a completed circuit. You can see here's the strober, and then I have a small test LED over here, and then up here I have power going to it, and then ground. So when I disconnect this, light turns off. When I plug it in, it's on and it strobes. Off, on, strobe. So for installation instructions, they're pretty simple because I tried to make the design as easy as possible. So basically, you have your gas pedal, your brake pedal. It comes in here, and it itself has like a little Schmidt trigger, something like this, that takes that ramping up voltage and converts it into a high, which then goes to your brake lights back here. All you need to do is cut in here and put in the circuit. This will be the red wire in the picture I showed you, and then yellow goes out to the brake light, and then the black goes to ground. So on this picture here, this is red, and this is black, and this is yellow. Those are the only 3 wires you have to worry about hooking up. So you just use those. It's like parasitic in nature. You don't have to add something like a fancy line or something. It operates on the power coming from the signal from your brake pedal. And that's it. Alright guys, that's going to do it for this one. Thanks for watching. Leave a comment if you have a question. Make sure you hit that subscribe button. I don't post very often, but when I do, it's usually interesting stuff.